Students, let us understand the valence bond theory with a simple example. We have taken nickel tetracarbonyl. Here this is the coordination compound. Okay, I have written stepwise. You just follow this one. The first step, you have to find out the atomic number of the central metal atom. In this case, the central metal atom will be the nickel. So the atomic number of nickel is 28. The second step, we have to find out the oxidation state of the central metal atom. Here, see here, this is a carbonyl group and it is a neutral ligand. Neutral ligand means there is no plus charge and minus charge, so it carries the zero oxidation state. If you do the simple calculation at last, the nickel also will carry a zero oxidation state. We have find out the oxidation state. And the third step, we have to do the electronic configuration. You know how to write the electronic configuration. Once if you have written the electronic configuration, means you just have to take the outer shell. Only you have to take the outer shell, which is nothing but the 3d8 and 4s2. Okay, then this one, you know what is this one? These are all called degenerate cells. Degenerate sets in the sense the orbitals which is having the equal amount of energy or the same energy. Okay, so what is the outer electronic configuration? 3d8 4s2. d orbital will have 5 degenerate set and s orbital will have 1 degenerate set and p orbitals will have 3 degenerate set. Okay, we have to fill the electrons according to the half-of principle. We know what is meant by half-of principle. Okay, first one electron is filled, then only the pairing take place. Okay, this is called half-of principle. So we have to fill the electrons 3d8. Okay, we have filled, then 4s2 I have written here, and this 4p orbital is empty, so I have written 4p0. Then the fifth step, you have to find out the nature of the ligand. Okay, what is meant by nature of the ligand? Whether it is a strong field or weak field, we have to find. In the valence bond theory, I think so, 8th point, they have told about the ligand. So carbonyl is the CO group is the strong field ligand. So we have find out the ligand is strong field ligand. Okay, carbonyl is the strong field ligand that you have to write. If it is strong field ligand, what is the work of the strong field ligand? It can pair up the electrons. Okay, the strong field ligand will pair up the electrons present in the degenerate set. You see here, in this case 3d8, these two electrons are not paired. Because of the strong field ligand, these two electrons can be paired up, because these 4s2 electrons can go to the 3d orbital. Pairing take place in this case. Okay, so I have written here. Then if these two electrons are going, means this 4s orbital will be empty. So I have written 4s0 and 4p orbital also is empty. Okay, then what else you have to see? You have to see the ligand. How many ligands are there? 4 ligands are there. Okay, each ligand donate a pair of electron. Each ligand donate a pair of electron in order to form the hybridized orbital. We need 4 boxes because each ligand donate a pair of electrons. How many boxes we need? 1, 2, 3, 4. Okay, we need 4 degenerate set. Okay, I already told that each ligand donate a pair of electron. Each ligand donate a pair of electrons. 4 ligands are there. It donates a pair of electron. Okay, what is the ligand? Carbonyl donates a pair of electron. Carbonyl donates a pair of electron. Carbonyl donates a pair of electron. Again, the carbonyl group donates a pair of electron. Okay, it forms the hybridized, or this orbital is called a hybridized orbital. 1s and 3 p's. 1s and 3 p's. This is sp3 hybridization. If the compound is having sp3 hybridization, the geometry will be the tetrahedral. geometry. You know how to draw the tetrahedral geometry. And the magnetism. Okay, so magnetism in the sense, listen here, you have to see the central metal atom. You have to see the central metal atom, not the other 4s and 4p. Okay, there is no unpaired electrons. Okay, if there is unpaired electrons, the magnetic property will be the magnetism. But in this case, there is no unpaired electrons, all are paired, so the magnetic property will be diamagnetic in nature. Okay, hence it is paired. Okay, then magnetic moment. Okay, you have to find out the magnetic moment, n into n plus 2. This is the formula. Here n is the number of unpaired electrons, number of unpaired electrons. Okay, there is no unpaired electrons, so the magnetic moment will be the 0. Then coordination number. You know how to find out the coordination number. It is very simple. How many ligands are there? 4 ligands are there, so the coordination number will be 4. Then hybridization, already we find out sp3 hybridization. Am I clear to you? Is there any doubt in that? If you have any doubt, you just ask me.